now to something important that we'll spend basically all the time, rest of this lecture time to look at, namely the planning part. And just 2 minutes for the last one, not so important. The planning part is important. We see it in 3 different, slightly different versions. We see it for 2, talking about the 1 sample case that we actually studied the last weeks, and then at the end, the 2 sample case. What do I mean by precision? I mean, precision is the confidence interval approach, right? What's the confidence interval? The confidence interval is, for a single sample, it's the t distribution, the t quantile, not an observed t, the t quantile from the distribution times s over this one. This is, you could say, should be careful now, if I say that I want precision, I shouldn't go like that. The precision is given by this number, right? This is the margin of error. The margin of error, we sometimes call it. So the confidence interval is plus minus the margin of error. If I want precision, is to say, so maybe I should emphasize, I'm in the planning phase. I didn't do my study. I'm going to decide how large an n should I pick for my study. My study has the purpose to estimate mu. I want to know how many engines should I check, how many people should I measure, how many concrete pieces should I crush, how many whatever, right? I'm the engineer. I'm the financially responsible, I'm the project manager, I need to decide. So, I decide I want a precision of, say, 0.01. I have a requirement to the precision, so when I do my study, I know I have this precision on my estimate. If I take that as the input, that I have some requirement to the margin of error, to the precision, to the width of the confidence interval, I could turn it around and isolate n in this one. It's all not exactly what happens here because we need to do a bit of a little approximation trick here. Basically, I have isolated n here, and then instead of t, I've put the standard normal quantile as an approximation. It's not because it's perfect, it's to have a simple formula. Because the problem of the t quantile is that it depends on n. So it's a difficult thing to have in a formula to find n, that it depends on n. For a computer, it's not impossible for a simple formula to use. So we make an approximation. We also make instead of s, we put sigma, because this is something that we have to use scenario-based, because I'm telling you I'm in the planning phase of my experiment, so I don't have any data, so I couldn't compute I couldn't compute s because I don't have any data. I'm about to decide how many data points I should collect to find some information about what I want. So here's the sample size formula, which is a scenario-based approach of trying to achieve wanted precision, right? If I have a requirement to the precision, if I allow myself to guess, or by external information or some historic information, if I think I know the sigma, or I can just do scenario-based, what if sigma, what if the noise is of this level, then I need so many observations. This is where it becomes a bit challenging, of course, because people come to you as a statistician and they ask you, how many observations should I have? And my first answer is, I don't know. How should I know? You're the expert. You tell me something first. You tell me what's the precision you want, and what's the noise of your system. If you can tell me those 2 things, we can find the right formula for you to find the needed n. But if you have no idea, I cannot help you. Or I can help you to understand that we could do some scenario-based computations to clarify your situation. Example. Now I'm just going back. I mean, maybe it's a bit unpedagogical, but anyway, of course we had some data here. It of course illustrates that sometimes you have some data and then you're still in the phase of how would I move on now? I'm going to do a new study next year or next month or next week. I have some historic information, and of course I want to use historic information maybe to move on, to plan a new experiment. So I'm planning. What if I would like to make a study where I collect and measure heights of people, and I decide I'd like a confidence interval? And of course I need to decide which confidence interval I'm working with. That's the other thing. So let's choose the usual one. If I want this confidence interval to be plus minus 3 centimeters, that's what I mean by requiring a margin of error of 3 centimeters. Then I can use the formula. I take the standard normal quantile, the one you should know, 1.96. I plug in some scenario-based or historical value for the sigma. This is just a guess in a way. It's not analysis, I'm just scenario-based, thinking about the future. And this formula would tell me with that requirement I would need to collect 64 persons. If I round up to be sure I'm below, you cannot be sure, but on the average that would be your choice, 64, right? So that's the precision version of our planning thing here.